man. Baby, what you doing? Say nothing else to fair. Girl, come with me. This is something you should.
Hi guys, welcome to our practice by Chemistry Face. This is going to be a really dry episode, so be aware. For 13, the question for 13 says, as electrons flow through complexes in the inner mitochondrial membrane, protons are moved from the matrix to the intermembrane space. This can make the pH blank. So the possible answers are A, lower in the intermembrane space, B, lower in the matrix, C, lower in both the matrix and the inner mitochondrial space, and D, the same in the matrix and the intermembrane space. So for 13, the answer was A, lower in the intermembrane space. That is because it is lower in the intermembrane space due to the increase in hydrogen ions. It is not B, lower in the matrix, because it is not because the pH goes up in the matrix because they lose hydrogen ions. C, it's not C, lower in both the matrix and the inner mitochondrial space, because it is only lower in the matrix, because the intermembrane space gains hydrogen ions, like we said in the previous class. And it's not D, the same in the matrix and the intermembrane space, because they are different. Like it's not related. They're different. Okay, but the answer was A. A said lower in the intermembrane space. Okay, so that's number 13. Question 14 for chiropractic for biochemistry in your face. The inner membrane of mitochondria is permeable to blank, but not to blank. So I'm going to repeat that again. The inner membrane of mitochondria is permeable to blank, but not to blank. So the answer was, the possible answer is A, the inner membrane of mitochondria is permeable to uncharged molecules, but not to charged molecules, or permeable to charged molecules, but not to uncharged molecules, so the opposite. That was C actually. And then B, permeable to cations, but not to anions, or D, permeable to protons, but not to water. Okay, so the answer was that the inner membrane of mitochondria is permeable to uncharged molecules and charged molecules, but not to charged molecules. Sorry, let me repeat that. So the inner membrane of mitochondria is permeable to uncharged molecules, but not to charged molecules. The reason for this, well, let's see why the other ones aren't. So it is not permeable to cations. So the answer isn't that it's permeable to cations, but not to anions, because cations and anions are both charged molecules. We'll see why when I explain A, why that can be. It can be charged molecules and uncharged molecules, because charged molecules can't pass directly through the inner membrane. So just there, it will not be permeable to that. And for D, it is not permeable to water. It's not permeable to protons, but not to water. It's not true because they're actually permeable. Not true because, sorry, this is not true because both protons and water are charged, so they won't be able to pass. So the answer is A. It is permeable to uncharged molecules, but not to charged molecules, because the inner membrane of the mitochondria is composed of a phospholipid bilayer. Due to its double membrane, it will prevent polar or other charged molecules from passing through the membrane, composed because of its orientation. So again, because it has the polar on top and non-polar on the bottom. In order for charged molecules such as hydrogen ions to pass through the inner membrane, they leave the protein channels that will let the charged molecules pass through that inner membrane. Could be a little confusing, but again, the answer is the inner membrane of mitochondria is permeable to uncharged molecules, but not to charged molecules. Hopefully you understand. Sorry for the dry episode of chiropractic for biochemistry in your face.
Work, 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 work. You see me heavy work, 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 work.